So our topic today, we are going to discuss automatic transmission operation and testing. And boy, that's a mouthful, but we're going to be focusing mainly on the electrical and control side because we're not going to talk about planetary gears or any of the physical hardware inside. It's going to be more of the control systems because that's really where diagnostics lives, is on the electrical side of things mainly. But let's talk through it. So first off, gear selection. How do I put the darn thing in gear? That's the first step. So there are a couple different ways, and the old classic way on an automatic transmission was the cable gear shift. It would have a cable going from your shifter to your to the actual transmission here. So this is on a Subaru here, and the cable would hook in there, and then it pushes this switch around. So it is a simple rotary type switch, kind of like a rheostat, I guess. You would test for continuity between the pins for each of the gears. Proper alignment is key, though. There are many vehicles out there. You can't do certain things. Most vehicles out there, you can't do certain things that needs to be in park or neutral or what have you. And sometimes you might have a starting issue because it's almost in park, like the switch is moved. The vehicle doesn't know it's in park unless this is operating correctly, of course. And some modern switches are internal to the transmission as well, so you can't even get to it without tearing the transmission apart. And then on this lever here, it is hooked to a valve in there, the manual valve, so it changes the fluid direction, right? So that's kind of one way to do it, and it would be in here. We can see that it has PRND, right? And then depending on where it is, notice how the park gives continuity and neutral gives park continuity to the starting and charging system, right? So that's going to allow you to start the vehicle in either park or neutral, not reverse or drive. And then in reverse, when it goes to reverse, which would be this one, it of course goes to the exterior light system because that's how it turns on the reverse lights in this vehicle case. And then of course all the gears kind of duplicate and go over to the transmission control module in this case, so that way the transmission control module knows what gear is where, and it is straight hardwired in this particular one. So park has its own wire, and reverse, and so on. So in order to test it, you would test it, between power and to the corresponding switch. So you'd run the switch through the gears, and that would allow you to do that. Also, on this vehicle, it has a sport gear shift. So you move the shifter to the left, and then you have an up and down switch for the gate. So it has a sport shift switch, which would go over to the left. It's like a little micro switch that would tell the vehicle it's in sport. And then when you shift it up, it's a micro switch, and you shift it down, it's a micro switch. And it would just be a simple, like I said, on-off switch. You test for continuity when closed. Alternatively, it could be a steering wheel paddle or switches, and usually in those cases, it's going to be more of a LIN bus type situation. So when you see that sort of thing, you'd want to look in the wiring diagram and see, okay, is it a LIN or is it just a micro switch as well? More than likely, it's going to be, especially in a newer vehicle, it's going to be a LIN situation. Then we have the wonderful world of knobs. So I always thought this was a questionable choice, design-wise, because you see we have the shifter knob, we have the volume knob for the radio, and we have the blower motor knob, all in really close proximity to each other. And if you're not looking, I don't know, maybe I turn up the radio when I'm trying to put it in reverse. I don't know. It's used in FCA and other vehicles. It is a digital rotary encoder, so it turns and it sends out digital bus signals. All communication on this is over the network, and you would use a scan tool to diag it. You could also, I suppose, check for a signal using a scope to see if you have your digital ones and zeros. Going through that. So here is the knob gear shift in this case. So it's just data bus CAN. So positive and negative, can see positive and negative, and then it goes out depending on how it's set up, and then of course send notice to the transmission control module where if it's in line or not, or what gear it's in. And then we went from knobs, and then we went to buttons. So there's a button gear shift. Used in GM and other vehicles. I've noticed it a lot in the GM vehicles for sure. Once again, this is all comm is over the network in this case, and you would use the scan tool to diag it. So push to park, I believe reverse and drive or lift up, and neutral's a push down or something like that. And then you also have your plus and minus to go up and down through the different gears. And as I said, there's a gear shift control module. That is the whole deal. And then sends out over network. So you should have network computer data to tell the vehicle what gear you're desiring. And then we went from buttons, now we're in stock mode. So GM and other vehicles, that's just taken out of a GM. So it's almost like we're back to the 3 on a tree, but it's automatic, right? Or just back to the automatic stock from when that you used to have in the olden days, back when I was growing up. In this case, it is digital though, again. So all comm is over the network, and use the scan tool to diag it. Just like I said before, you may be able to also use scope to check for diag. And this is also kind of interesting. So I noticed this going through the wiring diagram. So battery positive, of course, 2.5 volt reference, which is interesting. And then there's a 1.5 volt reference over here. So don't be looking for 5 volt reference on this particular item. You're going to have a 2.5 and a 1.5 volt reference. And you would need to know that if you're going to be testing it for voltage. So if you're expecting 5 volts and you see 2.5 volts, you might think there was a problem with it, when really, in reality, there wasn't a problem with it. So, and then if you sum them both up, that still gives you 4 volts, which is interesting as well. But that's just kind of how they do it. So we have the actual control module here, which is just where the stick is. And then it goes to the, in this case, the battery energy control module in there. So all sorts of different ways to shift it. Let's talk about the internals, the sensors. Well, it could be external, I suppose, as well, but the sensors. So most important on most automatic transmissions is going to be the temp sensor. So it knows, kind of what the temperature is doing. In this case, the one I picked is a negative coefficient thermistor. As temperature increases, the voltage will decrease. Other manufacturers could use it the other way, where temp increases, voltage increases as well. You're going to test it for voltage or resistance, really not complicated. Sometimes it is part of the valve body, and due to that, it could be difficult to access as well. So in this example, this is on a 01 Camaro 4L60E fluid temp sensor. It's a 2-wire thermistor. As the transmission temp increases, thermistor resistance and signal voltage decrease. Cold transmission, voltage is sent through a high resistance circuit in the PCM. On a warm transmission, voltage is sent through a low resistance circuit in the PCM. And it does switch. There's a switch over there. Dual circuit improves TFT accuracy over all temperature ranges. PCM uses it to signal to determine shift patterns, engage or disengage the torque converter, and determine hot mode operation. And then in this case, we can see the harness there. And then they give you this handy dandy resistance to voltage chart. So, and then there's your voltage here. So we can see it goes 5 volts to 1 volt, and then it switches over at 122 Fahrenheit. Goes 3.25 to 0. So very, very hot. At 302, it is pushing 0 volts in that case. Next, we have speed sensors. Usually they're going to be multiple speed sensors on a vehicle, at least an input and output, and that's for transmission speed, right? It could take vehicle speed off of the output speed sensor, but usually that's going to be wheel speed sensors. Usually in the case of the speed sensor on a transmission, it's going to be a Hall effect sensor. It's going to read input and or output and or other shaft speeds. You're going to test it for voltage and resistance. Sometimes it is part of the valve body, and because of that, once again, can be difficult to access. Sometimes it's all going to be part of one harness, and you just need to replace the whole harness as an assembly. So here's an example on Subaru Legacy. Now, they did have issues with early on these, is the 5-speed transmission. 5-speed automatic transmission. They came out with an 05. Through about 2010, they used it. And what would happen is internal to the transmission, where that sensor would read, the stack would shift. So if it shifted outside of the sensor area, then you would throw a speed sensor code. It really wasn't the speed sensor itself was the problem. It was actually a physical problem in the transmission that needed to be addressed. But this one did have, in this case, has 2 speed sensors. So turbine speed sensor 1 measures input shaft speed and torque converter speed. And speed sensor 2 measures transmission speed. And then we can see there's different sensors going on with that. So sensor 1 is on the driver's side of the transmission near the middle. You can kind of get to it from underneath. And then speed sensor 2, once again, like I said, it's in the valve body. So you're going to test it at the connector at the above the bell housing. And in this case, we're just looking at voltage, right? So vehicle stop should be 0 volts, at least 12 miles an hour. It's going to be more than 1 volt AC. So it's just reading AC right here. And just that's what you would see. You want to see voltage. GM has their speed sensors internal to the valve body. So that one mounts there and that one mounts there. On the valve body itself, it's kind of all part of a harness. And then it clips into the transmission control module there, which is part of the valve body as well. And in this case, it's got a little clip there that clips in. So you are not going to test this externally, more than likely. You're going to have to drop the valve body in order to test it. And then speaking of valve bodies are mainly just a bunch of solenoids in there, right? At least in a modern transmission, electronically controlled transmission. So there's 2 different types of solenoids. There's on-off solenoids, which is just like it says on the tin. It's either on or off. Computers control the ground side or the power side, depending on how the manufacturer has it set up. And it is an open-close function. Sometimes it is part of the valve body and is not replaceable, and because of that, can be difficult to access. But sometimes they put them right at the bottom, or sometimes they put them right in the back where it's nice and easy to get to. Just drop the pan. So in this case, we're looking at 06 Forester. Shift solenoids 1 and 2 are on-off type solenoids. They're power side switched by the TCM and grounded through the trans housing. And then depending on who is on and who is off, that is going to give you your gears. So both on is first, off and on is second, off is third, and on-off is fourth. And just based on those different configurations, it is going to get us our different gears. And then road test vehicle, when solenoid is turned on, meter reading should see battery. When solenoid is off, should be less than 1 volt. Refer to shift solenoid, apply chart for proper solenoid switching in each gear. And we can see that down there. Or it could be a pulse width modulated solenoid. So in this case, it'd be a modulated on-off type situation. Computer is going to control the power or the ground side, depending. It's going to open and close as a percentage of on time. Sometimes it's part of the valve body, and if it is part of the valve body, it might be difficult to access. So here's an example on a 14 Ford Explorer on the torque converter clutch solenoid on a 6-speed. Torque converter clutch solenoid is an integral part of the solenoid body, and being so is not available as a separate unit. So there we go. Torque converter clutch solenoid is both power side and ground side controlled by PCM or TCM on some vehicles. PCM and TCM controls common solenoid power used by all solenoids in order to cut power in case of a circuit fault. Solenoid duty cycle is controlled on the ground side to allow for smooth torque converter control or torque converter clutch application. TCM controls the torque converter lockup by varying the amount of current applied to the torque converter clutch solenoid. When no current is applied, it is fully released. When maximum current is applied, it is fully applied, and anywhere in between. So best place to test it is at the 20-pin connector at the transmission. And then we would see something like this. So it's duty cycle percentage is reading. So it went from, in this case, 40% duty all the way up to about, looks like about 75% duty cycle. In that case, converter is locked when it's at least 65%. And then on a 2011 Camaro, this has different solenoids as well. Normally high or normally low solenoids. Normally high solenoid allows pressure to travel to a clutch when the solenoid is turned off, whereas a normally low solenoid prevents pressure from getting to a clutch when the solenoid is turned off. Shift solenoid states are shown as normally closed. These solenoids allow oil to pass through them when turned on and block flow through them when turned off. And then we can see the different, so it's normally closed, normally high, normally low. And it looks like there are multiple solenoids on that. There's your state right there. And then solenoid controlling line pressure can be tested for a function using a scanner and a pressure gauge. Use a 500 psi pressure gauge. And if we come down, command a pressure change, it's going to give you the different psi's there. All the pressure control solenoids are programmed by the manufacturer to operate correctly together with the vehicle that the transmission is installed to. After being programmed to operate with a general set of parameters closely matching the assigned vehicle application, transmission was designed to operate with. The transmission needs to be operated through a number of shift cycles in order for the TCM to make the necessary pressure adjustments required for smooth and efficient shifting. That brings us to adaptives. So your transmissions, modern transmissions, are going to adapt with how you drive. So here's an example on a Challenger. To equalize tolerances and wear, an automatic adaptation takes place for shift time, clutch filling pressure, and torque converter lockup control. Adaptation data may be stored permanently and to some extent can be diagnosed. Shift point is modified in steps based on the information from inputs. Control module looks at inputs such as vehicle acceleration and decel, rate of change as well as position of the throttle pedal, lateral acceleration, gear change frequency. Based on how aggressive the driver is, the TCM moves up the shift so the present gear is held a little longer before the next upshift. If the driving style is still aggressive, shift point is modified up to 10 steps. If the driving returns to normal, then the shift point modification also returns to the base position. The adaptation has no memory. Adaptation of driving style is nothing more than a shift point modification meant to assist an aggressive driver. Shift points are adjusted for the moment and return to base position as soon as the inputs are controlled in a more normal manner. So if I want to start driving aggressively, it will adapt, and then once I stop driving aggressively, it will stop. Example on a Camaro. So service fast learn adapts as a procedure for 6-speed automatic transmissions in which a series of tests are run to allow the transmission control module to learn individual clutch characteristics. Once the clutch data is learned, service fast learn adapt translate to adaptive data cells, which the TCM uses for clutch control during shifts. And you will use the scan tool in order to do that. Service fast learn adapts procedure must be performed when one of the following repairs have been made. So transmission, internal service or overhaul, valve body repair or replacement, control solenoid valve assembly replacement, TCM software calibration update, or any service in response to a shift quality concern. Now we have different transmission types. So over the years, of course, we've gone from just your standard, clutch packs and sun gears and the like, which would be this hydraulic automatic. That's where we've been for most of automatic transmissions life, right? We got our torque converter, and then we have our clutch packs, and then we have our different sun gears and planetary gears and stuff like that, depending on which way it goes and which clutches get held and the drums get held and so on. Friction material in there, right? So that's a clutch pack in there. Sometimes you can just throw a clutch pack assembly in there and that can solve a problem. I know on the Subaru 4-speed transmissions, we were always replacing forward reverse clutch packs, or because when you would shift from reverse to drive, it would lag and then would finally clunk into gear, and that was just a worn clutch pack. So we could do that actually just kind of off the front of the transmission. You pull the old clutch pack out, you put a new clutch pack in, and you're good to go. So that's how it's been for a long time. And then, now we got a couple different types of transmissions. So another one is the Volkswagen Audi DSG. So that's a dual shift gearbox. So the way this works is it's essentially a manual transmission with a electronics package over here, and it has 2 clutches. So it's like a regular clutch, like a standard transmission clutch, but it has 2 of them. And due to that, it has 2 different input shafts. So one clutch is hooked up to the larger input shaft, and another clutch is hooked up to the smaller input shaft. And then depending on how it shifts, it will shift accordingly. So there's a couple of shift forks there, and it got 2 different friction materials. You got the smaller shaft on the inside and the larger shaft on the outside there, and it's got 2 pressure plates, and it is going to shift back and forth between those depending on what gear it is. So it's the odd number gears are on one shaft, and the even number gears are on a second shaft. So it just basically shifts back and forth between the 2 shafts as it shifts. And there are some scan tool functions that need to be done on that. BMW also has they call it a dual clutch transmission. So it is basically an automated manual transmission. In this case, though, it is not 2 clutches, like friction clutches, like you would see in a manual transmission on the Volkswagen. It is actually 2 clutch packs, like you would see in a hydraulically controlled automatic transmission. So we have these clutch packs here with the friction material, and once again, same type of idea. So you got an inner shaft and an outer shaft, and they're attached to the 2 different clutch packs accordingly to shift. And funny enough, cable shifts to control it. Interesting. And then we have CVTs. Some manufacturers have stuck with the CVTs. Some manufacturers tried it and then decided it wasn't for them, so they went a different way. And then the other thing with modern transmissions, they're obviously doing this to meet their fuel economy standards and make a better driving experience for the customer. So You get a CVT, which is infinite gears, or you might see like a 10-speed transmission on some trucks. So they kind of went different ways depending on the manufacturer. But a CVT, in this case, a Subaru one, it's got two variable pulleys in there with a metal belt in between. And it looks kind of like this. So we got our input shaft and we got our metal belt going between the two pulleys. And depending on how we slide the pulleys in and out, is going to give us different gear ratios, basically infinite gear ratios in there. And I know early on, customers kind of complained about it because like, well, I can't tell when it's shifting and it holds at 3,000 RPM, but I am just accelerating constantly. And it's kind of an odd feeling at first before you get used to it. But I have noticed nowadays that they add shift points to the vehicle. Like my mother has a 2017 with a CVT, and it feels like it shifts because they added shift points to the logic just so customers would feel it shift, I guess. But that's kind of how it works. So you can move; it'll move back and forth with hydraulic pressure. It'll push them in and out, and then it changes the gear ratio by doing that. Looks something like this, right? So you got your belt, and you got your two pulleys, and you got a pump there, and all that. Now the funny thing about that I always relate to it is we went through Subaru school to learn how to take them apart and rebuild them and all that. And come to find out, they teach you how to repair it and remove things and remove and install everything. And then they say, oh yeah, by the way, you're never going to do that anyway. We're just going to show you how it works, but you're never going to do it because if it's so much as leaks a drop, it gets a new transmission. So if it's a Subaru one, you're probably not going to end up taking them apart. Maybe another manufacturer, they might do repairs on them. I'm not sure how Nissan does it or whatever. But they are out there and they can be rebuilt as long as you can get the parts for them, I suppose. I'm sure there's remans out there now for it, and you're just going to hang a transmission at that point because they are a little complicated on the inside. And then just here's what that would look like in the the wiring diagram for that. So you got a TCM, everything goes directly to the different solenoids and such. So it's a linear solenoid here for our clutch, transfer, input clutch, etc. You got a couple speed sensors, inhibitor switch, front vehicle speed sensor, different switches for the brakes, the clutches, etc. And there's an oil pressure switch. So that's just kind of how it operates. It's all electronically controlled. You would do anything you need to do with the scan tool. All right, so let's go live on the tool. Got a couple choice vehicles for you. First one's a Volkswagen Taos. That's got that dual shift gearbox. So if we go in here, I'm gonna go in our transmission. Yep, sim mode, I know. This one. And then it was the OGC. All right, so on Volkswagens, by the way, another thing I'll bring up in here. So Volkswagen will have their functional tests secured behind security. So it's similar but different to the way like Chrysler does it. So Chrysler lock down the whole vehicle. You have to go through the security before you can even get in and do anything. On Volkswagen and Audi, it is at the functional test level. So I can get in and do a lot of stuff in the car. Then when I try to go into my functional test, for example, you will come up with a security link access, and then you will need to enter your profile access code. So with Snap-on tools, all you have to do is go into your Snap-on profile, which would be where you put in all your username and passwords for your auto auth and stuff like that as well. And then you're going to set up what we call a profile access code. So it is just a 4-digit code that you choose and you plug it in on the website. As long as the number you punch in here on this prompt matches what's on the website, then you get right in. So show you an example. This one's incorrect. So it's going to go and say, oh, no, sorry. So you get 5 total attempts to go through and get access to these tests. So instead of having to worry about tokens and all that other stuff, we just include it in the software. Once it's valid, it'll allow you in and it'll allow you to get to those tests. So we'll go to special functions and you see we have adapt installation info. So that's when you do any sort of work to it. Basic settings of transmission needs to be done after work as well. And then we have check oil level. So following steps are performed in this test program. It's going to check the transmission fluid level. Make sure shifter is in P, vehicle on flat level surface, lower engine noise insulation so the undercover is removed, and transmission fluid needs to be between 35 and 45 degrees Celsius. In this case, it's too high, so it's going to say, no, you can't do that. Basic settings, I'm going to go through there. Basic setting is only required after you do software adaptation, replacing the mechatronics, which is the electronics in there, replacing the clutch, event memory entry of a P175F00, transmission system basic setting not performed. The entire transmission is replaced. You don't need to do it. Put it in P, let it idle. It's going to be way too hot. And conditions not met. All right. And it's not going to be met because I'm in a simulator. So just exit out of that. And then add up installation info. Ignition on. Needs to be done after software update, after replacing the control module or the selector lever even, after work on the steering wheel paddles, after another control module is replaced like engine, ABS, or gateway. And it's going to set the basic settings. Basically sets it to factory. Not sure if this is going to time out or not. Looks like no. Okay. All right. So that's Volkswagen. And then I want to pull up this F350. So this one has pretty much any 6.7, pretty much, is going to have this test in the transmission. So if we go into functional tests, special functions, you see we have clear adaptives, halt adaptives, PMI, stop uses transmission adaptive, resume transmission adaptive learning, and then this transmission characterization and solenoid identification. So this is a time saver. So you don't have to pull it all apart when you're ordering parts. So let's think about, I'm going to have to order my solenoids perhaps if I'm doing transmission work. And I don't need the vehicle immobile while I'm waiting for the parts to come in, right? So instead of disassembling transmission, getting down to the solenoids and everything like that, I can actually go through and check the bands digitally using the scan tool. Just kind of pick your transmission there, and then it's going to tell you what the solenoid bands are. So ID numbers and different ranges, etc. So this will be used to order those actual parts. So I don't have to drop the pan. I don't have to do any of that. I can actually just see it right here before I go and order it. Then I order the right parts, and then continue from there. So, all right. And then also with this, we will have kind of component tests on this as well. So if I go into transmission, let's call it rear-wheel drive, 6-speed. So you see we got unrelated to transmission as well. Brake pedal switch, fluid temp sensor, line pressure, output speed sensor. Say output speed sensor. And then Hall effect. It's a Hall effect with bidirectional capability. Output speed sensor is a digital output. Reads gear teeth on the part gear, different teeth than teeth used for the part function. Input PCM or TCM for line pressure, shift scheduling, shift timing, torque converter, clutch operation, and vehicle speed. Use the output speed signal sensor as an input for the strategy of the shift torque converter clutch operation. And let's see, it's located on the left side of the transmission case above the pan in the middle of the transmission case. So a couple different connectors, a couple different signals. And you can do a DC voltage test on it. It's going to tell you what you need to see. Or a resistance test. Transmission information. Tell you how to ID the transmission. Shift solenoids, different solenoids. We talked about those. So single planetary gear set, one-way holding clutch, main control valve body unit, 2 multi-disc holding clutches, 3 multi-plate drive clutches, electronic shift and pressure controls, double planetary gear set, and torque converter with an integral converter clutch. See that there. And then, of course, we can do DC voltage or resistance tests. So it's going to tell you your different solenoids. And then, lastly, we're going to have this BMW. So that's got the dual clutch transmission. And on this one, DKG, yep, DKG. Special functions, we have oil balancing, oil adjustment, fluid adjustment, gearbox adaptations, teaching in of the clutch slipping point. So oil balancing. Idle speed between 550 and 800. Temperature between 30 and 40, or 30 and 50 when it's done. And then there are going to be three different scenarios where you might need to adjust the oil level. So faults are stored in the transmission control. It says oil level check. If the mechatronics or converters have been replaced, or parts have been replaced, no mechatronics, no converter. So let's say I did put it on the hoist, apply parking brake. With the oil filter plug, according to the instructions, with the engine turned off, fill the gearbox up to the lower edge of the filler plug, start the engine, immediately fill the transmission with oil again until it overflows. Current transmission fluid temperature is shown on the following screen, and it's going to say 770, I'm sure, or 723. Too hot, won't let me do it. But you would walk through and follow the instructions in order to do so. And then also in here, we should have a couple guided component tests on that transmission too. Mechatronics. So CAN bus, transmission ID, power and ground circuits, TCM pinouts. That's nice. There's my TCM pinouts. Fluid checking procedure. It even tells you how to check the fluid. So transmission must be cold. Start vehicle. Immediately remove the transmission fill plug. If it drips out with plug removed, the transmission temp between 30 and 50. Fluid level is okay. It does not drip, but the fluid level is low. And then here's how to fill it. All right. If not full, try it again. All right. So that is transmissions. Let's talk about what we're going to talk about next week. Next week, we are back to our OEM-specific ADAS training. This time it is Hyundai and Kia. So we're going to talk about the unique items that go along with the Hyundai and Kia ADAS systems. They do have some little weird things to go with them. So yeah, follow along if you want. 2 sessions, as always, every Tuesday, 6 and 9 Eastern. Go to snapon.com/OT if you want to join on Zoom. Otherwise, the 6 p.m. Eastern class goes live to our YouTube channel. So you can see it's youtube.com/Snap-on Diagnostics. Please make sure you like and subscribe. You can scan that QR code, brings you right to us, and automatically subscribes you as well. And then the 9 p.m. Eastern class goes live to our Facebook page. So it's facebook.com. On Facebook, it is Snap-on Diagnostics Product and Training. If you want to see any of the other episodes in this series, we've been doing this for about 5 years. We have 126 episodes for your viewing pleasure, with more to come. Anywhere from intro to ADAS through EVAP system diagnosis and everything in between. So they're all roughly, half hour, 40 minutes long, depends on the subject matter. And you just go check free diagnostic training. Lots and lots of free diagnostic training. So definitely make sure you check that out. Once again, youtube.com/Snap-on Diagnostics. Do we have your email address? If we don't have your email address, then you're missing out on some good diagnostic-related content, such as tech focus articles, SureTrack blogs, quick tips, new product releases, etc. Here's an example on an email about stretch timing chain and diagnosing that. So if you are not getting those emails, scan that little QR code right there, and it'll bring you to a form you can fill out to get your email entered, and then you will be able to receive those emails. And also, they send out my schedule periodically as well, so you'll know what's coming up for class. All right, time for questions. If you did join on Zoom and you were a little late and you don't know where to go, just look for that Q&A button, top or bottom of your screen, type it in there. And then I will also on YouTube use the live chat function. So looks like Nick is nice and busy on YouTube tonight. Hello to everybody. It is late for you, so get some rest there, Nick. Jaylee Lobo, hello. Welcome as always. Let's see. Thank you very much for providing free training. Can't wait for next week. Alex Tolstoy is checking in, saying hello. Hello. Nick has a suggestion for a inside vehicle heating, outside cold, near side hot, you're bleeding, coolant system, carry out head gasket test. Yep. Did that on Subarus a lot. All right. That's about that. Looks like we got all the questions. So thank you very much for spending a little bit of time with me. Hopefully you picked up some tips and tricks on automatic transmissions and their operation. Hopefully we'll see you next week for Hyundai and Kia. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.